So good evening, my people. Welcome to my channel. My name is Amos Onyisi. As you have known, I'm a LinkedIn creator, and at the same time, I'm trying to document most of my learning process on YouTube. Project I've done, I need to document it on YouTube so that people can make reference with it. And one of them I want to talk to you about is funnel analysis. This is a process where people who own landing pages, websites, and retail store try to understand customer interaction with their store, and at what stage people tend to leave their stores. Okay, if they have people visit their website, especially those in the e-commerce, they have people visit their website, how many visited, how many end up making purchase or making payments or end up buying their product. That's what funnel analysis is all about. Okay, and trying to check the various conversion rates. So without wasting your time, I will jump into the project so that we won't waste much of our time. Okay, so this is our screen which I want to share with you. So this is the project. First and foremost, we notice that we will start with the business problem. This business is experiencing a low conversion rate across its e-commerce funnel and want to identify where users drop off, okay, to improve their overall revenue performance. First and foremost, I would love to install pandasql. This is one tool that I use on the Google Colab environment to run SQL query. So it's quite easy. It allows you to have everything you are doing in one interface. You don't need to clean some part of your data, later go back to SQL to do some of the SQL work in your data. So now that our PySQL is imported, we click on this code to make sure that we bring it to our local notebook. Then these are the necessary libraries. Some of these libraries are not needed. It's just that we have to, I just copied it from a machine learning project that I worked on. So some of them, like all we needed is the pandas, import pandas as PD, import SQLite, then our PySQL, where the one we are going to be working with so much, the seaborn, the warnings, to avoid most of warnings, the NumPy, and the likes of it. So we will not be doing any machine learning model, so there won't be need for most of the libraries. Without wasting much of your time, as you know, before you work in any Colab notebook, you have to import the data we are working with. As you can see, I've imported it. The name of the data is user event. So we now run the code to read our data set. So as you can see, our data has been read. Just like any Python data set, we now have various columns. Now let's try to understand what those columns stands for. We have the event ID, the event or what we conducted, what can we identify it, what is the unique identifier. Then the user ID, people that are visiting us, what is their identifier, people that are visiting our website, sorry. Okay, then we have the type, event type. Are they just viewing us, are they adding to cart, are they checking out? Then we have the event date, when did this actually happen? Then we have the product ID, what are those various products that people are uh, going to, are purchasing from our website. In this case, that's where the product ID distinct various product that this site or this service provider is providing. But mind you, the amount column in this case is going to have a lot of null values since most of the people are not making purchases. As you can see, the amount column has a lot of NA values. Then the traffic source talks about where are people coming from, where are we having people from. Is it organic, is it social, is it email, or the likes of it. Next up, we are going to look at, do we have missing values? As you know, we run our missing value to see if there are missing values. We saw that amount, like I said, had about 8,555 missing values. Those are the people who never made payment. That's the missing value. So in order for us to treat our missing value, knowing fully well that the amount column is a numeric column. We can't fill it with unknown. We have to fill it with 0 so that we can carry on and standardize our data. So we now draft this code df amount, then fill any with 0. By the time we run it, it will fill our amount column with 0. So we move on to the trying to understand the data. First, we want to check what are the various unique products that this organization is selling. We saw that with their product ID, 404 is highly sold with about 1,646. We saw that 205 have close number with 1,611, then 201 and the likes of them. Those are the unique product that the site is selling. So for us to run SQL queries, like repeating what we have done already, mind you, this is very important. For us to run it as a SQL query, we must impute this query equals, then we put this sign and run our traditional, end it also with SQL df, so that we can return it while whenever we are we are running SQL in a notebook, especially Google Colab, because this is one of the notebook I use all the time. Okay, so after doing that, majority of this analysis you are going to be doing, we try to check the unique dates. Okay, here we are looking at the unique dates of people, when did they interact with our website. And sometimes whenever you see 3 dots here, when you enter the unique dates of any column, it's trying to tell you that there are lots of numbers that it could not present. Okay, that means all the numbers were not present. Okay, so we now go ahead to check for the types of events. So at the various stages, we have the page view, people that added to cart, people that check out, people that added their payment info, and people that made purchase. Let's take it this way. For a website, people tend to view our website from different sources. They just see it, they saw the ad, they click the button. Then people that add to cart are people that actually pick interest in our products. Okay, why they check out, they picked interest, but at maybe stage of payment they couldn't wait, there was traffic delay, the website is not loading, they have to drop off after they have added the product to cart. So but for payment info, these people have already brought out their card to make payment, but because of a lot of detail, a lot of verification, a lot of hidden charges, maybe they just realize that they have to pay for transport, export charges and all of that, they withdraw and cancel. They couldn't proceed to add their payment detail. Why the purchase talks about people who end up buying the products that we are selling. So the next stop is we are going to look at the data type of all our columns to see if they are in their right data type. We saw that, of course, the events what's it called, event ID is in the right data type of integer. Sometimes if you want to visualize it, we can take it to object so that we could bring it to best visual, but we do that later in this project. So the next stop is we have our event type. Okay, we've talked about it, is in the right type of objects. Then we have the product ID, traffic source object, where we talked about how people come to notice us. Then the first thing we are going to count is the total number of views we have, the total number of people that add to cart, and the total number of people that check out, and the total number of people that almost made payment but couldn't, and the total number of people that made purchase. For us to calculate that, we have to use a CTE, and just like I said, before we start any query, we start with query equals, then this sign, then we draft this CTE, we said with funnel as. Okay, then we select the we count the distinct event type, okay, where it is equals page view. Okay, then the user ID, end it, and we rename it as stage view 1. We can rename it as anything. We do the same for event type where people add to carts with unique user ID. What does this do? It helps us count the number of people who viewed our page, unique number of individuals who viewed our page, and maybe they drop off. It also go ahead and do the same for add to cart. It go the same. We did the same for checkout. We did the same for payment info, and did the same for purchase. Then when you come here, we now select from df, just normal SQL slash Python function, but here we are using SQL. Then we are going to use a condition. Why are we using minus 120 days? You discover that this data is coming from a streaming data. In order for us to get all the detail, I have to backdate it to from the source. That is why I was able to take it to what's it called, one minus 120 days, in order for me to get all the details of the data. Okay, so by the time we run this, we now saw that the total number of people, sorry, let's excuse me. Okay, like I said, it's still running. The total number of people who viewed our product is 5,000. As at the time, like I said, it's coming from a streaming data. As at the time I did this project, it was about 120 days. So if if another days, maybe a month is added, I have to increase the number of minus of days. That means it has gotten to 5 months since this data was generated. Okay, since it's coming from a streaming data, by the time the day reduces, these errors always occur. So we have the total number of viewers as 5,000. Then this 5,000, out of them, large amount of them drop off before they could add to cart. In other words, they didn't just pick interest in our products. Then some, they pick interest, but they still drop off along the line. Some try to make payment, but maybe one factor or the other stop them. Why? About 89 tried to make payment, but they couldn't. Why 826 made payment and purchased our products. As you can see, out of 5,000 that visited or view our product, view our page, only 826 made purchase. Okay, that's something that should bother us as a business. Then the next thing we are going to be looking at is that we want to calculate the conversion rates at various stages of the funnel. Okay, let's make these changes to 150 so that we could cover all the interval, knowing fully well that our data is streaming data. So we want to know the conversion rate. We use the same SQL code that we have been working with, but this time we are trying to look at, okay, give us a minute. After counting it, bringing in the first cities, we try to look at the stage 1. We divide what's it called, the stage 2, which is this people that added to cart, stage to cart. We divide it by stage 1 view, in order for us to know the what's it called, the let's put it this way. In order for us to get people that move from just page view to adding to cart, we have to divide the total population of people that are at that added to cart with the total number of viewers. Okay, I hope that makes sense, so that we know that, okay, this is the conversion rate. So we did that for all the stages and rounded the figure so that we could have a rounded figure. So for stage 1, we divide stage 2 by 1 and we times it by 100 in order to have percentage. Then for 2, we did the same. We divide stage 3 checkout, which is checkout, by stage 2 cart, which is people that added to cart, and call it cart to checkout rate. You know, people that from cart that add to cart to the point they made checkout, what is the rate? Then for stage 4 payment, we divide the stage 4 payments by stage 3 checkout. In other words, for you to have the what's it called, conversion rate at all stages, you divide the previous stage by the present stage and times it by 100. Okay, I want to calculate, for instance, this stage 4 payment. I would divide stage 4 payment by stage 3 checkout, which is this one. Okay, because I'm trying to understand the movement of people at various stages. It's like, okay, we subtract the number of people uh, that move from one stage to another, then divide it and the likes of it. That's the mathematics behind it. So after doing that, we now saw that the same mathematics apply, that we have about 5,000 view because we added the distinct count. For stage 2, for us to have our conversion rate, we divide this by this, 1553 divided by this. Let's try and do that with calculator. Okay, by the time we do that, let's see if we have 31%. 1553 divided by 5,000. Okay, as we can see, that's 31%. So the next thing we are going to do is to divide this 1103 by 15. Okay, by the time we do that, we see that our conversion rate, our next stage conversion rate, we what's it called? Okay, let's run this code first. Let's see what we got. Okay, we saw that the conversion rate now is about 31%. Okay, from this stage to this stage. Okay, then we saw that people at checkout to payment rate, a lot of people moved from checkout to payment rate. Okay, then 31 people, just this is trying to tell us that from what's it called, stage view to to add to cart, only 31% moved to that stage. Then from checkout, what's it called, add to cart to checkout, 71% people moved. Okay, then from payment, that's from checkout to payment, 81% move. That's a great number. Then from payment to purchase, about 91% move. At that stage, we were really not losing a lot of people in the funnel. So the largest drop off occur at the view to cart stage, which is at roughly 69%. So the next thing we are going to do is to calculate the drop off stage at the various stage of the funnel. This time we are trying to look at where do people drop off the most. Okay, in order for us to do that, we still bring our distinct count. This time we are still going to conduct the same mathematics, and we select first the view to cart as stage. We have to rename it a bit. View as stage users, cart as end users. So after doing that, we round our figure, we round our numbers, then view minus cart divided by views, we round it to 2, and we call it as drop off. Then we are selecting from the funnel, then we are unioning all. By the time we select everything from cart to checkout, and also the carts, we select our checkout, we round it to 2 again. Then we are minusing carts from checkout divided by carts. Okay, just like what we did earlier. In order for us to come home with our solution, we are selecting it from funnel, which happens to be our data set. So we still unioning another stage because we are looking for 5 different stages. So we select checkout to payment, we call it checkout. We select checkout also payment, then we are rounding it. We minus checkout from payment, we are dividing it by checkout, we round it to 2. Then we do the same for payment to purchase, and we select payment and purchase. We are rounding it to 2. We minus payment from purchase, divide by payment, and we are rounding it to 2, just like I said. Then we select the CTE, which is select star from drop off, order by drop off descending. In other words, which stage has the highest drop off. So let's go and check our result. By the time we run it now, we could see that a stage has the highest drop off is from view to end users. Okay, what this means is people tend to view us, but they don't pick interest on our product. About 68% just drop those interests. Imagine having 5,000 visitors come to your website, just 1,553 end up picking interest. About 68 to almost 69% is lost. Okay, then that 1,553 moved to the next stage. We still lost some numbers. Okay, from add to cart to checkout, we lost some numbers. About 28% was lost. Then from checkout to payment, we still lost some numbers, which is 18%. Then payment to purchase, we lost some minimal number of 8% of those population that we have carried along. So the percentage was not much, but overall 826 end up making purchase. So like I wrote here, I said we lost most customer at the very first stage, which is about 69%, just like you and I have talked about. So next we looked at also using Python to look at the various view. We check it to confirm what we have done already. Then we check for duplicates. Do we have duplicate? The answer is no, we don't have duplicate. Now we are going to calculate drop off by traffic source. Which of the traffic source is actually having the highest drop off? So we are going to count by event type, because our traffic source is sitting in the events type column. We are still going to work with CTE. Then first we bring in our query equals, then we put our code. Then this time we are calling the CTE as source data as. Then we select our traffic source, which happens to be our let's say our major area of concern. Then we count. We said distinct case when event type equals page view. This we are using both CTE and case statement here. Okay, this is like a conditional statement. When event type equals page view, then user ID. In other words, give us the user ID when event type is equals page view. Give us the unique user ID, and we are renaming it as view. I hope that makes sense. It's like, okay, we are giving a condition that whenever event type is page view, give us their unique ID. That's what this thing is saying. Give us the distinct user ID. Then we go to the next condition, which says count distinct case when event type equals add to cart. Same condition. When people event type is equal to add to cart, then give us their unique user ID, and we are going to call it cart. Then after doing that, we are, of course, you know how we end every SQL statement from. That's the source of the data. Then we are grouping it by traffic source. Okay, then at the end of it, we now select the traffic source, the view, which we have created here, the cart, which we also created here. Then we are rounding it. We are minusing view from cart and dividing it by view and rounding it to 2. I hope this makes sense. Don't forget, we have created our view, trying to know the distinct number of people that have viewed our page. And also we are trying to know the distinct people that added to carts. Okay, so after doing that, we now come back here and select our traffic source, the same view we've created here, the same cart we've created, and round it up to 2, timesing it by 100. We now put a bracket and say view minus cart. Okay, number of people that viewed our product minus the number of people that added to cart divided by the view, which is 5000 minus 1553 divided by 5000. We are calling it drop off, or drop off percentage. Okay, so where are we selecting it from? That is our CTE. By the time we close it now, we are ordering it by drop off descending. In other words, the highest drop off will come first before the lowest drop off. Whenever you see descending, that's the case. So we now saw that social media is giving us the highest drop off point at the very top stage. It's standing at 86.4%. Why organic? People that search us, maybe they just saw us naturally, they just search our name on the internet and they find our product, they are dropping off at 67.17%. Then for paid ad, 63.0%. Paid ad goes area of Google ad or any means we've paid people to advertise our product, maybe affiliate marketing and the likes of it. But for email, we had a drop off point of 37.5%. So we are seeing that social media is giving us the highest drop off point. Email is our good mile here, I must confess. So next, we are going to calculate the percentage rate between new and returning customer. Let me explain here. As a business, we will not just always focus on marketing. We will also want to know what is the percentage rate, at which rate is our new customer converting and maybe returning customer converting, so that we know places we are channeling our advertising energy towards. If we are going to be giving more incentive to already existing customers, or if we are going to pay more to ads. I hope that makes sense. Okay, so doing this, we are going to draft a SQL code that distinct the conversion rate between our returning customer and our existing customer. Okay, so for us to do that, we draft a SQL code, then we start with our CTE, then we select the user ID, the minimum event date as first event time, which is what we are trying to say is the first time this person approached our business. Okay, then the maximum here we are giving another case statement which says when event type equals purchase, then 1 else 0. In other words, let me explain what we are trying to say, what SQL is trying to say. If our event type is equals to 1, sorry, if our event type is equals to purchase, that is, then we are looking at this person bought our product, else they didn't buy the product. The event type may be anything, maybe viewing, maybe add to cart, they just viewed. But once it is purchased, that means they end up buying our product. Okay, and we call them as converted. So where are we getting this data frame? That's still our data frame, which is df, and we are grouping it by user ID. Okay, so let's go another condition that we are going to meet. Okay, we are saying user type as, that's another condition. We select our our user ID, then the converted that we've calculated here, then we make a case statement. Okay, then when our event date equals the first event time. Okay, in other words, what SQL is trying to do is that we are dictating a distinction between this particular condition here and our data frame. Whenever you see e dot user id, we are looking at our old data frame. I hope that makes sense. Then whenever you see you, we are looking at this particular data frame we conducted here, or this table we drafted here. So our old data frame, whenever user id and this converted table, okay, because we are going to join it together, then we now say in our old data frame, if the event date is equals to user dot first event time, then we condition it as new. Okay, if the what's it called, the event time or event is equals to new, then let me digress a bit. What we are trying to tell you is that if event date in this particular condition that we just met is equals to new, then is equals to first event time, then we are categorizing it as new, else we are saying returning. Okay, then the end, in order to end it, we are going to use, we end it as user type, which happen to be the what's it called, the beginning of the condition. Where are we selecting it from? DFE. Like I said, our our, our initial data frame. Sorry for that break. So we are going to join the user summary. We are going to join the user on, we are going to join the two table on user ID. Okay, where user ID for our old table with our user ID on the second, which is the new table. By the time we do that, we come down again and draft a select statement that select both the user type, average conversion rate times 1.0 as conversion rate. Then from user type, we group it by user type. Now at the end of it, we saw that generally our new customers convert at 16.5% by the time we times this with 100, while the returning customers are converting at 75.4%. So returning customer tend to convert more than the new customer. Then the next thing we're going to be looking at is calculate the numbers of products sold by their unique product ID. This is something we can do easily. All we need to do is to calculate, use the count function. We select the product ID, we do count star, which is count all, as total product from, which is our df, where event type equals purchase. Okay, we are trying to count the various products that people end up purchasing. We are grouping it by products ID, order by total purchase descending, which is this total purchase we have here. Okay, so by the time we do that, we saw that people tend to purchase a lot of 205. Okay, even earlier when they were not one of the most viewed products, we saw that they recorded the highest purchase, followed by 404, and as the number keep decreasing, so we keep going. The next thing we are going to look at is we are calculating the hours of the day with the highest conversion rate. Okay, we are looking at what time do people tend to convert the more. In other words, if we are conducting a campaign, which time are most of our users active on the internet? This is what we want to know. Okay, it will be important because it allows us to know time to launch our campaign either on social media or reach out to people via email. Okay, we now start our query. You say with hourly view as, we select it, we cast the strip time. Okay, we set it as integer and we make it as hours. Then we count the numbers of views. Then we make sure that we are selecting from our data frame, which is df, where event date equals page view. Okay, that's the condition. We are grouping it by hour. That's the first condition we are meeting. So we are now looking at hourly purchase as our next condition, if you may say. Then we select and cast the same thing we did here. As you can see, we are counting the total numbers of purchase. Here we are counting view, here we are counting purchase. From where? The data frame. Where event type. What change between this condition and this condition is that one is page view, the other one is purchase. Okay, we are looking at page view by hour and purchase by hour. So we go ahead and create another condition where view.r and viewed v.r or view.r and view.view, or as you may like to call it. Then we collapse it as p.purchase equals 0. We name it as purchase. Then we collapse it again. If p.purchase equals 0, then we are dividing this v.view, which is the numbers of view we have, as conversion rate. Then from hourly view.v, which is numbers of view we have by hours of the day. Okay, that is the first condition we generated here. Okay, just know that. Okay, as you can see, so by the time we join it, we do a left join on the hourly purchase as p, and we are joining it on hours because both of them have hours on it, and we are ordering it by v.r. We will now see that these are the various purchases and views, and also the conversion rate we have by various hours of the day. Okay, so we can now spot out the time that has view if it is correlating with the purchases and the conversion rate, because of course the purchases we have to determine the conversion rate. We saw that at 14 o'clock 14, which is when the time is 24 hours, we have a 20% conversion rate. About 41 purchases was made. Okay, then out of how many people that viewed our product? 199. But at 4 o'clock we saw that 233 people viewed our product. About 46 made purchase with a 19.7% conversion rate. So that is it for this. So most of the times these concepts are kind of technical, talking through it and at the same time trying to tell you what it is, most times it's kind of hard. So pardon my lapses actually. So now we are going to calculate the conversion rate by weekdays. So which of the weekdays has the highest conversion rate? First, we are going to extract the weekdays from the event date column. That's why we have this particular code here. Okay, so after doing that, we now write our query where weekday underscore view, and then we select our weekday as weekday. Then we count the total numbers of views, okay, for those weekdays. Then where event type equals page view, we are grouping it by weekdays. I hope that makes sense. We are trying to count the total number of page view we have for each of the weekdays, say Monday, Tuesday, Wednesday, Thursday, and all of that. So we want to also count the total number of purchase we have by weekdays. Okay, so as you can see, we have weekdays purchase as. So we are going to do the same. We are not just looking at view, we looked at purchase. So we can see we saw weekdays view, weekday purchase, we collapse it. Then by the time we are done, we now check what these weekdays are. If Monday is 1, Tuesday is 2, and the likes of it. So when we run the query, we now saw that this is the result. As you can see, this is our result, with Monday having the highest conversion rate, followed by Sunday and Wednesday. So most of the conversion rate always occur on Monday and Sundays. Okay, so we are getting deeper into the analysis. Now we want to calculate the number of purchase by traffic source. Okay, we are not just trying to know, okay, we made purchases of 826, how many is coming from each of the sources. That is what we want to calculate here. Now we are selecting traffic source and counting, using also the distinct count of case statement to check if event type equals page view, then user ID. Give us the distinct user ID as view. Okay, then we still do a distinct count of event type equals add to cart. We do the same, then we call it as cart. When distinct count is, we use a case statement to, if event type is equals to purchase, then user ID equals purchase. Then we select everything from the data frame where the event date is equals to or greater than. Then we come here to correct our 150 days so that it will carry out all we need to do, knowing fully well that it's a streaming data, just like we've noted earlier. Then we saw that a lot of purchases were done by organic, standing as the highest. Okay, we saw, despite the fact that they have about 2038 people viewing our page, only 669 added to cart, and about half of that, almost half, more than half of that, made purchase. Okay, and why are we uploading email? They have one of the lowest view, about 522, and yet 320 added to cart and 177 made purchase. Look at some other media such as social. We have 1400 coming from social, only 200 added to cart and 102 made purchase. So that is poor for our, I would say that will be a poor performance, and we could be happy as a member of the management as people are buying our product organically. As you can see, we are not spending anything. People are buying it. About 346 people just buy without us spending on ads, and these people could maybe make refer our product to family members. So the next we are going to do is we are going to calculate the cart to conversion rate. Okay, we are going to calculate the various conversion rates, okay, at various stages. What we are trying to do is what is the various sources conversion rate. In other words, what is the conversion rate of say organic from cart to purchase to what's it called, to the final stage. So in order for us not to make this a very long video, we are going to see, we saw that organic email has the highest, about 62 cart to conversion rate. Then of course organic stand at 33, paid ad is at 37, then social is at 14. So if you want the scripts, I could drop it in the comment section. Just comment it, I'll drop it for you later. Then the next is calculate the time user spend. This is very important. What time, how long do people spend on our page? Okay, so let's walk through what we did here so that you won't feel lost. Sorry, let's go back a bit here. So we use the CTE to calculate source funnel as, then we check our traffic source. Just like we've done before, we count the distinct type when page view and the user ID is unique. Then we do the same for event type when people added to cart. We do the same for event type when purchases were made. Then the user ID. Then we select everything from our we select from our data frame where event date is greater than or equals to, now we've changing to 150. Then we are grouping it by traffic source. Okay, so in the next condition, we are selecting our traffic source, our view, our carts, and our purchase that we've calculated earlier. Then we are rounding the number up. Then we now say cart times 100 divided by view. That is our cart conversion rate. That's the number of people that added to cart in that particular stage. Then we round it up again and divide, we times purchase by 100 divided by view. That is our purchase conversion rate. That's the number of people who made the number of people who purchase, okay, the conversion rate of the purchase, sorry. Then we looked at the same for purchase and divided by cart, and we say cart to payment purchase conversion rate. Sorry for that misconception, sorry. So from where are we getting it? Just like any SQL code, we are using it, we are selecting the initial CTE, which is source funnel. Okay, don't mix it up, because after CTE, after any CTE, you are going to select the particular CTE you are working with. This time you are ordering it by purchase descending. Okay, this is what it means. We are going to look at the highest purchase. I hope we get. Now we saw that the highest purchase is coming from organic, followed by paid ad, followed by email, followed by social. Okay, so having said that, we saw that uh, cart conversion rates was heavily noted under email, but others were heavy. But paid ad has 37, organic has 33, social was really not good. Purchase conversion rate was still okay for email at 34, then followed by paid ad, followed by organic 7% for social, that's poor. Then cart to payment purchase, this was mixed up in terms of spelling, sorry guys. We have organic at 51, paid ad at 57, then email at 54, then social at 51. So next, now we are seeing that email and paid ad bring in the most valuable customers, like I've written here. Organic source bring in the most people, but they are less likely to purchase immediately, just like social media. Okay, so let's keep going. Now we are going to calculate time people spend on our page. Why do we need to know this? We need to know, okay, time people are spending in order for us to know if they are scrolling past our page or not. So by the time we run this code, we saw that on average, although people that have converted, average view to cart, people spend at 11 minutes 16 seconds. Average cart to purchase, what this is saying is, at the stage of viewing our products before people add to cart, they spend 11 minutes on average. Then on average, from adding to cart to people to for people to make purchase, they are spending 13 minutes. On average, their total journey is 24 minutes. Okay, if for instance maybe we discover that payment info, the number is quite higher than we anticipated, or we have noticed in this analysis, we can work to reduce this add to purchase average cart to purchase minutes. In other words, time people spend before they could make purchase, because some people tend to get frustrated when they are unable to make purchase. Maybe they are buying something online, they try to bring out their card, the internet shut down, or the system is just slow. So that's what we are trying to calculate here. So the next thing we are going to do is we are going to check the revenue, which happens to be what's it called, the basis of every analysis. We are trying to see what are we generating, what's the breakdown of the revenue. Okay, then we start with funnel revenue, then we count we use the distinct and the case statement. Distinct is trying to tell SQL that give me the unique, just like the unique in Python. Okay, then we say when event type equals page view, then the user ID. Mind you, we are taking this unique entries. Okay, we are taking this total page view, total number of people that viewed our page, their user ID, and we are calling them as total visitors. Then we do another count and say case when event type equals purchase. Who are these people that made purchase? Okay, we are taking their user ID and call them total buyers. Then we are summing them up. Okay, when event type equals purchase, then amount equals total revenue. In other words, we are adding up all the amount of people that made purchase. That's what SQL is trying to do for us here. Then we are going to do another count and say case when event type equals purchase, then event ID, we end it and call it as total order. Okay, in other words, we are not adding the amount, but we are just getting the ID of these people that made purchase and calling that particular entry as order. By the time we add the amount, it turns to our revenue. Then we are selecting it from the data frame. Where event date is greater than or equal to, then we still backdate it to 150 so that it can give us what we want. Then, knowing fully well that we need this date we have calculated, we select our total visitor, total buyer, total revenue, then total order. Then we come up with our next case statement. Okay, then we now say case when total order is greater than 0, then total revenue times 100 divided by total order as 0, end as average order value. Okay, I know that's hard to digest, but with time, by the time you go through this video, you will try to understand, get a similar data frame, or if you want, I can drop the data frame at the description of this video so that you can walk through with me. Then you say another case statement, case when total buyer is greater than 0, then total revenue times 1.0 divided by total buyer, which we have calculated here, as 0, end as revenue per buyers. What we are trying to do is average order value and revenue per buyer. That's the second condition. Then the third condition is when the total visitors is greater than 0, okay, then total revenue is times total revenue times 1.0 divided by total visitor. Okay, then s 0.0, then end as revenue per visitor. Then we are selecting it from our funnel revenue, which we have created earlier. By the time we run this code, we will now see that those entries we need has been returned for us. We saw that total visitors, just like we have been working with, is 5,000, and our total buyers is 826, and of course our total revenue is 87,990 $987,000. Then total order is 826. Average order value is 106.5, and of course revenue per buyer 106.5. Then revenue per visitor is 17.5. So next we are going to try to visualize this funnel that we're talking about. Okay, where we talk about visitors, We talked about page view, add to cart, initial checkout. Okay, so by the time we are done, just like any funnel, we will see that the shape changes as people drop off. Okay, then we saw that the value we have 5,000, 1,553, 1,103, 899, 826, and all of that. Then we now saw that the text info, we have value plus percent and all of that. We are going to be adding percentage to it. Then this talks about the coloration of our funnel. Okay, this talks about the layout and styling. Okay, this talks about the title, the mood, which is stacked, and this is our final result. By the time we run this as code, ladies and gentlemen, this is our final result. Okay, so we saw that 5,000 visitors came. Okay, we saw that only about we have about page view of 1,553, product page view, then 1,000 what's it called, excuse me, I guess there's a mix up somewhere. Okay, product page view standard sorry, there's a mix up in the write up. 5,000 is the product page view, 1,553 is people that added to cart, then checkout is 1,100, and let me make the correction here, sorry, let me not bother you. Okay, let's swap this with, okay, here is our checkout, then here is our payment info. People that try making payment, but maybe the process was too cumbersome that they drop off. Okay, then we now call this add to carts, not page view, sorry, we are all humans. Add underscore to underscore cart. Okay, so let's view it now. This is what our visual ought to look like. As you can see, we have visitor about 5,000 visited, which is the 100% of people that viewed our product. 1,553 added to cart, 1,103 made it to checkout, 899 try making payments, only 826 end up making purchase. So that's it about this funnel analysis. So all these are not quite necessary, is what we have done in the past. So if you like this video, do well. This is the final note. We could see that there's a lot of lapses that the business could work on. So if you give me a minute, I would like to walk you through the visuals that I worked on in this particular project, if you don't mind. Let's see how it looks like. So give me a minute. We have noticed that indeed the business is having a lot of areas that they need to work on. Okay, so if you need the full detail of this particular project, I will drop a link to my portfolio website where I gave all the description that you need to know. Okay, all the description, I mean it. So this is the total visual of the business. We saw that about 68, which we have noticed, which we have written earlier, we have 5,000 users. Then we know that just the data is from 2 years, 2025 and 2026 is quite current data. That's why we have to adjust dates in most cases. Okay, we are conversant with this funnel. Then we saw that organic gave us 37 amount of traffic by source. We saw a lot of traffic from organic, followed by paid ad, followed by email, followed by social. Okay, then we are moving towards total revenue by month. A lot of revenue, sorry, total revenue by products. That's what this is supposed to be. A lot of revenue came from 205. So we saw a line graph trying to tell us which days of the week give us the highest. 14,700 coming from Sundays, Friday following the suit, followed by Monday, followed by Saturday. So guys, that's it. If you like this video, do well to subscribe, share with friends, and till I see you in the next video, I remain your boy Amos the analyst. Thank you for watching.